subscribe and press this bell icon to never miss another lecture video. Welcome to GATE ESE Lecture. We are in lecture number 58 of Signal System. Now here in this video lecture we are going to discuss about various properties of exponential form of Fourier series coefficients. Okay, so we know I'm talking about exponential form of Fourier series coefficient. I'm not talking about trigonometric Fourier series coefficients. I'm not talking about an and bn. I'm not talking about them. These are trigonometric Fourier series coefficients, right? For exponential form of Fourier series coefficients means I'm talking about Cn. So we're going to discuss about various properties of this Fourier series coefficients, that is your exponential form of Fourier series coefficients, that is your Cn. Okay, now a lot of people who you guys are like commenting me ki sir, just do it in a black background, it's so there are a couple of problems that I saw, so that is why I preferred black background. From now onwards I'll prefer this black background only in order to make you comfortable while you are seeing this. But please comment me below whether it is more useful or the blue background is more useful. Whichever is comfortable for your eyes, so I'll go with that color. Okay, now let's get into the actual core concept that we need to discuss. So we know the Fourier series representation in exponential form. So what is the Fourier series representation? Sir, there will be a summation, sir. Okay, summation is for what, sir? N tends to minus infinity to infinity, sir, which will be nothing but, sir, Cn into e to the power j n omega t, ओमेगा नॉट टी सर. ओमेगा नॉट क्यों है हम लोग सर फोरियर ट्रांसफॉर्म के टाइम पे समझेंगे. वेरी गुड. सो दिस इज द exponential form of representation of a periodic signal. Clear? This is the exponential form of representation. Now what is this? Cn is nothing but how much in the same period, that is your t. That is, if you can take minus t by 2 to t by 2, you can also take 0 to t by 2 as well. So you can also take 1 by t, 0 to t. Now where n omega naught is, look here, n omega naught is your what? Harmonic frequency. It could be a plus or minus harmonic frequency. Okay, where f naught, if you take out, it's like 2 pi f naught. So f naught will be fundamental frequency in cycles per second or hertz. Cn will be your Fourier coefficient. This Cn will be Fourier coefficient of exponential form. We know this thing. Now we are going to discuss couple of properties of this Cn. Now look here carefully. I am going to take, if I am taking x of t as my signal or as my mathematical representation of a graph or a signal, then the subsequent coefficient will be Cn. And if I am taking yt as a signal, the subsequent Fourier series coefficient, exponential coefficient, will be dn. So if you take like this, then the property of linearity will be nothing but listen to this carefully. If in continuous time periodic signal it is in this form, if it is in this form, the Fourier series coefficient, the subsequent Fourier series coefficient will going to obey the same order that is there. That is why I'm calling you, this is following the linearity behavior. Clear this concept, clear this linearity property. Now time shifting, look here carefully. X of, if you are doing the time shifting, x of t minus t naught in time, continuous time domain. Then the Fourier series, once when you represented the same thing in Fourier series format, if you represent this continuous time periodic signal in exponential Fourier series format, in that format you will get your Cn, instead of Cn x of t का Cn था ना, तो x of t minus t naught का हो जाएगा x of Cn into e to the power minus jn omega naught t naught. Clear? This tn will going to come here. So अगर ये x of t plus t naught हो गया तो यहाँ पे minus t naught हो जाएगा. Clear? सर वैसा वाला क्लैरिटी है सर, आप समझा के बोर मत करो सर. ओके, नाउ लेट्स अंडरस्टैंड फ्रीक्वेंसी शिफ्टिंग. फ्रीक्वेंसी शिफ्टिंग सर, हाँ, अगर इफ आई एम अप्लाइंग ई टू द पावर माइनस जे एन ओमेगा नॉट टी into x of t. Okay, let's make it not make it jn, just make it m, okay, because n is already here. Then it will going to be in terms of c of n minus m. So whatever the value in terms of n, that will be replaced by n minus m. Clear? Please write it down in your own language. Then your next property is conjugation. कंजुगेशन में प्रॉपर्टी कुछ ऐसे दिखेगा. अगर इफ़ यू आर टेकिंग अ कंजुगेट of your continuous time signal, if you are taking conjugate of your continuous time signal in a Fourier series representation, it will going to take c of minus n का conjugation. And if you are taking x of time reversal, look here carefully, time reversal, look here carefully, if you are taking time reversal, that is x of minus t. If you're replacing x of t by x of minus t, then your subsequent cn will going to be replaced by c of minus n. Clear this concept? Now if we do time shifting, time scaling, we have done. Look here, we have done the time shifting, we have done the time reversal, and let's do the time scaling. That means I'm going to replace x of t by x of alpha t. Okay, and x of t is a period with period t by alpha. Okay, where alpha is greater than 0. Okay, so in that case cn will not going to change. Remember this point. Now there is a very interesting property is there in multiplication. Sir, multiplication, हाँ, look here carefully. If you are multiplying two signals x of t into y of t, okay, both are periodic signals and both are having their own Fourier series coefficients as Cn and Dn respectively. So I'm sorry, let me put it in another color, x of n into y of, x of t into y of t. If you are doing this, then the subsequent Fourier series coefficient will be Cm d n minus m, where summation m for mango, m tends to minus infinity to infinity. Please write down these properties in your note papers. It's a very important property. Okay, similarly it is all about multiplication. Now if you do the differentiation, that will give you d by dt of x of t, that will going to give you d by dt. If you're taking differentiation of continuous time domain, if you're taking the differentiation of the Fourier series, differentiation of the periodic continuous time signal, then you're going to get in Fourier coefficient, that is Cn, will going to be multiplied, very important, j n omega naught के साथ ये multiply होके रहेगा. Okay, now look here. This is all about differentiation. If you took the integration, if you take the integration, देखो क्या होता है, if you take the integration in, if you're taking the integration in definite time interval like minus infinity to t, that is x of t dt, okay, that will give you 1 by jn omega naught into cn. Clear? 1 by jn omega naught into cn. That means finite, it is only the integration is only working in a finite duration. Now listen to this carefully, for periodic convolution, if you are taking x, that means what, x of tau y of t minus tau d tau in continuous time domain, अगर इनका ले लिया minus infinity से infinity, then you know what will be the subsequent Fourier series coefficient will going to replace. So that will be t, the period, the main period, t into cn into dn. सर ये खाली मल्टीप्लाई हो जाएगा फ्रीक्वेंसी डोमेन में? हाँ, कन्वल्यूशन में, द कंटिन्यूस टाइम डोमेन में, विल अंडरस्टैंड दिस कॉन्सेप्ट इन फोरियर ट्रांसफॉर्म. क्या होता है, इफ़ यू आर टेकिंग कन्वल्यूशन इन कंटिन्यूस टाइम डोमेन, द सब्सिक्वेंट फ्रीक्वेंसी डोमेन will be the multiplication of that two factor. X of t is real. Look here, Cn will be C of minus n, the conjugate of C of minus n. The magnitude of Cn will be equals to the magnitude of minus of Cn. Okay, also listen to this carefully, the phase of Cn will be equals to negative of Cn. Very important, it can be asked in your GATE exam, very important property. Okay, also let me put it in another color. Also listen to this carefully, a real part of Cn will be equals to a real part of C of minus n. Okay, imaginary part of Cn will be equals to minus of imaginary part of minus n. Clear? Imaginary part of minus n. It is very important. I'm really sorry I could not do the derivation, but the derivation is very important. I'm sorry, the derivation is not important, but this analysis is very important. Okay, it is for symmetry of signal. Now look here carefully, if you are talking about real and even, if your signal is real and even, यहाँ से अब ये जो 3 पॉइंट हम लोग डिस्कस करेंगे, रियल एंड इवन, और अगर रियल एंड ऑड है, इफ इट इज़ अ रियल एंड ऑड, if it is real and odd, and if and the Parseval relation, these three properties are very important for your GATE exam. Okay, listen to this carefully. If for real and even, x of t is real, if your x of t is a real and even, as the property is saying, x of t is real and odd. Okay, now let me guess, what would be the Cn if your x of t is real and odd? Cn are imaginary. Please remember this. I'm really sorry. And odd. Please remember, very, very important. If your x of t is real and even, then Cn are real and even. Sir, these are the same na? हाँ. If you are keeping your x of t is real, even, like अच्छा बच्चा, then your Fourier coefficient will come out to be रियल एंड इवन। इसका सारा ना एनालिसिस मैं आपको नहीं कर पा रहा हूँ। ये सारे एक प्रॉपर्टीज़, जितने भी सारे प्रॉपर्टीज़ दैट आई एम डिस्क्राइबिंग टू यू नो, सो आई वाज ऑलवेज लुकिंग फॉर दिस प्रॉपर्टी कि कहाँ पे एक जगह पे ये दिया हुआ है। देन आई गॉट अ वेरी गुड बुक जहाँ पे ये सारे प्रॉपर्टी एक जगह पे बड़े ही अच्छे तरीके से दिया है। सो आई प्रीफर टू रिप्रेजेंट दिस प्रॉपर्टी टू यू, दैट्स इट। क्योंकि इसके सारे जो डेरिवेशंस है, वंस आई स्टार्ट डूइंग द डेरिवेशन ऑफ ईच एंड एवरीथिंग ना, इट विल टेक 100 आवर्स ऑफ लेक्चर एंड इट्स नॉट नेसेसरी एक्चुअली। गेट के लिए प्रिपेयर होना है तो ये सारी चीज़ें आप बस लिख के एक बार नोट पे रख लो, एग्ज़ाम से पहले आप इसको थोड़ा रिवाइज करके चले जाना, और कुछ नहीं है इसमें। खाली रिमेंबर करने का चीज़ है ये वाला प्रॉपर्टी, ये वाला प्रॉपर्टी एंड ये वाला प्रॉपर्टी, these two properties. Okay, what is that Parseval relation? I'll tell you, but you know average power, listen to this carefully, we know this average power. What is the formula of average power? Sir, average power is 1 by t integration from 0 to t sir x of t का mod का square dt sir. this is the relation of average power. limit t tends to infinity ऐसे करके था, ऐसे माइनस टी बाई टू से टी बाई था और ये 1 बाई टी था, ऐसे करके आप कैसे भी करके लिख सकते हो. we know this relation. this is the relation in continuous time. P in terms of Fourier series, in Fourier series coefficient will be, look here carefully, so the power will be summation of, in terms of integration I replaced it, summation n tends to minus infinity to infinity cn mod ka square. Is that simple? That's it. Now what is a Parseval relation is saying, in time domain, in continuous time domain, you're having a function like 1 by t integration 0 to t x of t ka mod ka square dt, which is nothing but equals to, okay, so this term represent the power in nth harmonic component of xt, okay, and the total average power in periodic signal is equals to the sum of power in all of its harmonic, okay, that will be your what, total average power. Thank you so much for watching this video lecture. In the next video lecture we'll get into the discrete time domain mein Fourier series ka analysis, that is Fourier series in discrete time domain. Okay, we'll quickly finish that the couple of property, but that is not so much important for your exams, but we'll touch all those points which will be explicitly useful for your exam. Okay, thank you so much for watching. See you. Bye.